This is video 4. In this one, we're going to talk about some safe circuit designs. Now, when your circuit is not grounded, it is unpredictable. There's no way to guarantee how much or how little the voltage would exist between any point between your circuit and the earth. Now, when you ground one side of the power system's voltage, at least one point in the circuit would present no, you wouldn't have to worry about getting shocked. So here we have an example of this. So looking at this, because the circuit is grounded, if someone were to come up and grab a hold of that wire, they would be safe. Unfortunately, though, if this person were to grab a hold of the wire here, they would not be safe. So we do have to worry about being safe with these circuits. Another way of having a safe design would be to use switches. So for example, we could have two switches on here. This one would be our on-off, while this one would be a disconnect. All right, let's take a look at a simple design for an electric appliance, like a refrigerator or a toaster or something. Usually those appliances are covered with a metal sheet. So here's what we have. This part right here is in your house. So in your house you have your power supply, you have your hot wire going to the plug, and you've got your neutral wire coming back from the plug. This is where you plug it into the wall, and then here you have your appliance. And has a metal case on it, and there's no voltage between that, and ground. Right now, this is a safe design. You don't have to worry about people touching any hot wires inside the appliance. However, what would happen if, let's say, the appliance becomes damaged and one of the hot wires comes in contact with that metal casing? Well, as you might imagine, this could cause a severe problem. Someone could really get hurt from this. So in many homes, we have a 3-wire plug. And what they do is they attach to the metal casing and they go to ground. That way, if someone happens to touch the metal casing, they're still safe because the casing is still being grounded. And the grounded case ensures that there's always a 0 voltage drop between the case and the ground. So if you've ever wondered why we have 3 plugs on our outlets, that third plug typically looks like this. We got 2 and then this one. This third plug right here is the one that goes directly to ground. Okay, the last thing I want to discuss is how to properly use a meter. Meters are something that measures something with electricity, whether they're measuring voltage, current, or resistance, or power. And it's one of the most valuable skills you can have as an electrician or an electrical engineer. Typically, there are things called multimeters. They measure, they can measure voltage, current, resistance, and a lot more, like they can test diodes and a few other things. So right here are the parts to this digital multimeter. We have our probes. Typically, red is for positive, black is for negative, or common. And the wires are called leads. We have our plugs, and we have the tips. On the multimeter, we have different ports. This is where we plug in the common. This port is if you want to test the current. And this port is if you want to test voltage or resistance. So when you go to measure voltage, first off, you want to make sure that you plug everything into the correct spot. And typically, again, we put the red lead on the positive, the black lead on the negative, and we get a value in the multimeter. On the dial for the multimeter, we have different settings. The one that has like the little graph at the sine wave is for AC voltage. The one with the straight, the two parallel lines is for the DC voltage. You do need to be careful. When you're testing for voltage, make sure that your leads do not intersect because you can create a short circuit. Measuring resistance, it's very simple. You just make sure that the multimeter is in the correct setting, and then you just put both leads on either side of a resistor. The most common is the carbon film resistor. We'll be looking at those later this year. Um, really, really easy, and you don't even have to worry about hurting yourself with that one. You just have to make sure the multimeter is in the correct setting. Okay, measuring current. This is a little different. When you measure current, make sure that the lead is in the correct place. Also, make sure that you're measuring in either DC current or AC current. If it's a battery, it's always going to be DC. Also, current is, to measure it, it has to be a part of the circuit. So notice how this lead, this red lead, goes through the light bulb over to the positive side of the battery, and then from the negative side of the battery back to the multimeter. The ammeter has to be a part of the circuit. There's also many different numbers on the dial for these multimeters, and it's really easy to blow a fuse while measuring current. So, one thing I always want to tell my students is to make sure you double check the setting and make sure you know how much current will be going through the meter before you ever take a measurement. And that should be true of anything. You should know what voltage is going into that meter, what resistance is going into that meter, what current is going into that meter. You need to know that before you ever take a measurement. All right, well, that concludes the electrical safety unit notes.